Welcome to T&D Talk, a special series on the T&D World Line Life podcast channel. For each episode, companies can share their stories about how they are supporting the electric utility industry. Through their tools, technologies, products, and services, they are helping line workers and field workers improve their productivity and safety. This podcast episode focuses on the top things utilities should consider to ramp up resilience and reliability during the storm season. Our guest is Dr. Yushin Hawig, Vice President of Applications Engineering for Southwire. She holds a PhD degree in polymer engineering from Case Western Reserve University in Ohio, with a diverse career history, including the National Institute of Standards and Technology. She has been an author of 20 technical journal publications since 2001, a writer of over 200 technical white papers, inventor of 6 U.S. and international patents, and guest speaker for IEEE conferences and the Southeastern Electrical Exchange Trade Association. She has been an active management board member for NETRAC/Georgia Tech since 2015. Yushin, thank you so much for joining us for this episode of T&D Talk.
Thank you, Amy, for having me.
Yushin, to begin, can you describe your role at Southwire and talk about your engineering responsibilities?
Yes, I've been with Southwire for 15 years. I have been leading Southwire's cable tech support application engineering for over a decade. Our engineers custom design products and assist end users in specifying the most suitable solutions to meet the industry codes and standards. Southwire, we deliver power responsibly, and our engineering team is proud to support this corporate vision as well, with the goal of building the grid of the future.
Thank you so much. I'm so glad you're here with us on the podcast today. Now I'd really like to talk about storms because that's something that our Line Life podcast listeners are very interested in. Can you now describe the increase in the frequency and intensity of storms and how electric utilities are handling these changes?
Last year's Atlantic hurricane season was the most destructive in nearly 2 decades because there were 18 named storms, and 5 of which were classified as major hurricanes from the coast of Florida to Georgia into the foothills of North Carolina and Tennessee mountains. Southwire's headquarters in Carrollton, Georgia, was surrounded by devastation in these neighboring states. Our electric utility customers and partners in this region were significantly impacted. In the aftermath of the storms, we experienced a surge in storm-related orders and post-storm recovery inquiries. Fallen tree limbs and flooding caused severe damage to electrical systems. Customers ask urgent questions such as, do I replace? Can I repair? If replacement isn't available, how much time do I have before the system fails? If the replacement product isn't available, what are the alternative options? Is there a safe and temporary fix to restore the power quickly? From a strategic standpoint, short-term disaster readiness may include increasing the inventory for the most vulnerable overhead assets. From long-term planning perspective, upgrading the aging infrastructure with more robust electrical systems is essential.
Overhead lines are subject to all natural disasters. What is the most common solution to improve wildfire resiliency of overhead conductors?
Converting overhead lines to underground systems is not only time-consuming, but also extremely costly. One major advantage of covered conductor, also known as tree wires, is the speed which they can be deployed to replace existing bare overhead lines. This practical wildfire hardening solution is designed to reinforce the bare overhead distribution lines rated at 15, 25, or 35 kilovolts. That's one of the key reasons why utilities across the U.S. have replaced more than 10,000 miles of traditional bare overhead conductors with cover conductors. Adding this extra layer of extruded polymer has proven to be one of the most effective methods of mitigating wildfire risks, especially on the West Coast. How? By reducing the risk of arcing or sparking from bare wires during the windy conditions and dry seasons. Cover conductors are custom designs with multiple layers of material. The outermost layer is made from a cross-linked, high-density polyethylene material featuring UV resistance and excellent track resistance to withstand harsh environmental conditions.
Next, let's move on to undergrounding. Let's talk about the difference between copper and aluminum cables and how they perform under heavy loading and adverse conditions underground.
As the electric power demand continues to rise exponentially, higher system voltage ratings are being specified, and also super large conductors are required to deliver increased current or maximum ampacity. My engineering team is observing this growing trend in the specification of super-sized medium voltage power cables rated up to 46 kilovolts. This large medium voltage cables often feature stranded copper conductors sized at 1250 kcmil or 1500 kcmil and larger, frequently pushing the limits of standard manufacturing equipment designed for medium voltage cable production. Aluminum conductors, on the other hand, offer a lighter weight design and a more cost-effective alternative. However, the conductor must be upsized to match the ampacity of copper. In many cases, aluminum might fall short in terms of the electrical performance needed to support projected load growth. Additionally, aluminum is mechanically softer and more chemically susceptible to oxidations and corrosions, making it less suitable for harsh environments, such as nuclear power plants, wastewater treatment facilities, or industrial sites.
So, with storm season right around the corner, Yushin, can you talk about what utilities can do to make their underground systems storm ready and protect their infrastructure against harsh environments, including flooding?
This is one of my favorite topics. Water intrusion is one of the primary causes of cable system failures. Water contains oxidizing agents, which trigger the corrosion of the conductor, metallic shield, and also accelerates the dielectric breakdown of insulation material. As a result, a double or triple water protection for underground medium voltage cable has gained more popularity in recent years. More than 80% of the new cables have at least one type of water blocking component. This can be achieved by longitudinally filling the stranded conductor with water blocking compound, or applying a semiconductive water soluble tape, or dusting water blocking powders under the cable jacket. The powder used in water soluble tape is also known as super absorbent polymers. It is a cross-link material which has the capability of absorbing water up to 100% of its original volume. Fun fact, this powder is very similar to the powder you will find in baby diapers. The cross-link gel will retain the moisture and minimize the penetration of water along the cable length. The water blocking components under the overall cable jacket can minimize the degree of neutral corrosions long term.
That's very interesting. And now let's talk about some of the other critical design attributes to power the explosive growth of AI-driven data centers, renewable energy, and EV infrastructure.
This is a hot topic. Instead of direct burying cables in the ground or pulling them into a raceway on a job site, contractors can adopt an all-in-one cable and conduit system. Cable and conduit, also known as CIC, not only reduce labor, shorten installation time, but also helps prevent injuries on the job site. Whether it's medium voltage cable or 600-volt cables, can be pre-assembled into a high-density polyethylene conduit at the factory, streamlining the installation process. This all-in-one solution minimizes injuries, reduce downtime, and waste. CIC can prevent cable damage during shipment, handling, and installation. It can also prevent tearing and puncture to the cable jacket during installation. Another fun fact is the high-density polyethylene material is hydrophobic in nature, repelling water and offering a low moisture vapor transmission rate, which extend the life of the conduit. Overall, CIC systems can deliver up to 50% improvement in the total life cycle cost, a compelling advantage for modern infrastructure projects. In conclusion, CIC systems can deliver up to 50% improvement in total life cycle cost, which is a compelling advantage for modern infrastructure projects. CIC is a smarter and safer installation solution for all critical infrastructure projects.
And now I'd like to talk about the tools offered by Southwire. And I understand that you offer more than 10 free engineering calculators online to enhance the reliability of the electric grid. Could you share some of the most frequently used tools to design underground medium voltage cables?
Certainly, it is called the Concentric Neutral Calculator, a free online engineering tool available on Southwire.com, with mobile versions also available for download to any digital devices. With copper prices remain volatile, many of our customers, including utilities, are actively seeking ways to reduce material costs. One effective solution is to optimize the amount of copper used in neutral wires for medium voltage cables. Southwire's Concentric Neutral Calculator empowers users to design made-in-America medium voltage products to support grid modernization, renewable energy integration, and all the bipartisan infrastructure initiatives. This tool help to reduce neutral wire content and saving costs without compromise electrical safety. It is important to know that if you reduce too much of the copper content, it will impact electrical performance because of the lower short circuit current capacity. This tool helps strike the right balance by offering over 200 design combinations, including 25 conductor sizes in both aluminum and copper, 13 neutral ratings to meet specific project or customer requirements. It also allows you to choose between 90 degrees C or 105 degrees C as the maximum continuous operating temperature for the conductors. With this neutral calculator, engineers and planners can make informed decisions that optimize the performance, safety, and cost efficiency for medium voltage cables.
So your company also provides an online cable pull calculator that has been used by various industries, including utilities, for more than 20 years to assist in preventing installation damage. Yushin, can you talk a little bit more about that?
Absolutely. We see more than 1 million uses on this calculator per year, so it's one of the most popular tools. Southwire has offered an Excel spreadsheet-based cable pull calculator for over 2 decades. While it was once a reliable tool, it has become somewhat outdated because it can no longer support the complex cable pulling configurations required for today's advanced product types used in power generation, hyperscale data centers, and utility projects. To meet the demands of modern infrastructure, Southwire is launching a smart digital cable pull calculator that integrates a comprehensive wire and cable specification library. This dynamic tool delivers highly accurate calculations tailored to real-world scenarios. It features go versus no-go indicators and warning flags to alert users to potential pulling risks. Whether the project involves a semiconductor plant, a battery energy storage system, or solar farm, everyone will have access to this engineering planning tool, regardless of the number of pulling segments, route length, raceway types. Users can rest assured there will be no unexpected errors or damage during even the most challenging pulls. Southwire's next generation cable pull calculator will be smarter, faster, and more accurate. So please stay tuned as it will be launched this fall.
Wonderful. I think that will be wonderful for the industry. And the last topic is one of the most interesting. We have heard about wildlife intrusions on electrical systems. Can you tell us about what your experience has been in this area?
Of course, wildlife attacks on electrical wiring is indeed a fascinating engineering challenge. Wild animal intrusions on electrical systems can occur in a variety of environments, both above ground and below grade. Copper serves as an excellent deterrent against pests and wild animals due to its natural physical properties, including hardness and mechanical strength. To address this issue, my engineering team has developed single and double shielded substation power and control cables. These products are designed to mitigate wildlife attacks on low voltage wiring systems rated up to 2 kilovolts. The additional copper layer helps prevent damage caused by a wide range of animals, including rodents, rats, moles, squirrels, gophers, and even termites. Copper tapes are incorporated to protect the dielectric insulated phase conductors from severe chewing damage. In addition to its physical and mechanical benefits, the extra copper shielding also mitigates electromagnetic interference, or EMI, which can result from high voltage or extra high voltage equipment at the transmission or distribution substations. This shielded multi-conductor cable has been successfully adopted for utility applications and is equally suitable for critical infrastructure projects such as data centers, seaports, airports, wastewater treatment plants, and healthcare facilities.
Yushin, thank you so much for joining us for this episode of T&D Talk, sponsored by Southwire. We appreciate you giving our Line Life podcast listeners tips and strategies on how to improve grid reliability and performance in the field.
I enjoyed all the questions. Thank you, Amy.
Thank you again for joining us for the Line Life podcast. And if you're interested in learning more about Southwire, you can go to www.southwire.com, or you can go to linelife.podbean.com to listen to Part 1 and Part 2 of our T&D Talk series sponsored by Southwire. T&D Talk Part 2 is focused on novel innovations in T&D to ensure a reliable electric grid. And the guest for this episode is Charles Holcomb, Director of Overhead Systems and Solutions for Southwire. You can also listen to part 1 titled Empowering Demco, the Role of Southwire's Data Analytics and Grid Management. The guests for this episode are Mark Phillips, Chief Engineering and Operations Officer for Dixie Electric Membership Corporation, or DEMCO, a member-owned Louisiana-based electric cooperative, and Ray Caston, Vice President of Digital Solutions for Southwire. Thanks again for listening to the Lion Life podcast. And to listen to our interview-style episodes and audio stories in our In Case You Missed It series, you can go to lionlife.podbean.com and click follow in the top right to subscribe to our podcast and listen to past episodes. Thanks again for listening.